Hi, and welcome to Chapter 11. Chapter 11 is going to cover a concept called inheritance, which is built on the concepts from classes from Chapter 10. Inheritance allows you to do some amazing things with classes, lots of code reuse, polymorphism, we get into stuff like that. So let's get started. The first thing to explain is what is inheritance. So we talked about classes. Classes are objects, nouns that can be used to hold attributes and methods. In this case, we have a class that extends another class. The same way that you inherit from your parents, these classes can inherit from each other. So in some programming languages, we talk about it called inheritance. Some is called extending. We extend the class. And all it means is that we can use the attributes and the methods from our parent class in our child class. There are three different ways that we refer to inheritance. Sometimes it's called a parent-child relationship, where you have a parent class and the child inherits from the parent. Sometimes it is a superclass and a subclass. The superclass is the first class that you started with, and every class after that is a subclass. Kind of the way we type things in biology, where you have a superclass and then underneath that you have multiple subclasses. And then we can also refer to them as a base class, the class that you started with, and then derived classes, classes that can be derived from the base class. So you'll hear me use all three of these interchangeably. And that's intentional. I want you to get used to hearing all three words, or all 6 words, so that you understand how they interact with each other. When we talk about inheritance, we like to refer to it as an is-a relationship. You have a poodle is a type of a dog, or a rectangle is a type of a shape. So as long as it is another type, you can understand the vision between a parent and a child class. The parent would be the dog and the child class would be the poodle. Or the parent class, the base class would be a shape, and all of the derived classes, circle, square, rectangle, those can be derived classes off of your shape. So understanding that relationship between the superclass and subclass as an is-a will help you to visualize when you're looking at the different class types with inheritance. In this class example, we are giving you a lot of pieces of code on one page. So first we have looked at our automobile class. So we've made a class called an automobile, and since you've already done chapter 10, you should understand most of the things on the automobile side. So we have our class name, our keyword class, with our class name automobile being a capital A. Class names always start with a capital, and then our colon. We have our initializer, our constructor, the initialize that takes both the self, the object itself, the instance object, and then 4 other attributes: the make, the model, the mileage, and the price. And these are 4 different things that we associate with all types of vehicles. No matter what type of vehicle you're talking about, it has a make, it has the company that made it, it has the model number, it has how much mileage is on the vehicle, and then how much the vehicle costs. So whether it is a car or a truck or an SUV or an RV or anything along these lines, they all follow these same 4 basic attributes. We could add in things like color, where it's registered, vehicle license number, things like that as well. But for right now, we're just going to have these 4. We have our string overloaded function, where we can use that string every time that we want to print our object. We can just call the print function, and it'll return a string so that that can be printed nicely. So we talked about these in chapter 10. Then we have our getters and setters. So none of this should be new to you if you finished chapter 10 and you got through classes. Now we're going to look at our car class, which is the smaller class over on the right hand side. Our car class is a type of automobile. So it is a automobile. It has that relationship. So the car is the subclass, whereas the automobile is the superclass. The car is the child. The automobile is the parent. In this case, the car has an additional attribute of how many doors it has. That's the thing that we're going to say is different about a car. So a car has a number of doors. So we are going to use our initializer to be able to add in the doors attribute as well. When we look at our car class, because our car is inheriting from our automobile, we are going to put the automobile class name inside of parentheses with our car class. So you'll see the automobile class, there were no parentheses. In our car class, there is a set of parentheses, and our automobile class name is going in there because that is the parent of this object. So the superclass. And then we have our colon, same way you would expect it. In our initializer, we have to take at least the 5 attributes that are in the initializer from the base class, because we're going to use that base class to initialize this object as well. We are also going to add a 6th attribute of the number of doors, so that when we call this car object, we can give it how many doors it has. The first line under the initializer, our constructor, is our automobile initializer function. And you'll see that we called automobile dot and then initialize. We didn't say new automobile at this point because we don't want to create an automobile. We want to create a car. So we're not going to create a new automobile. We're going to create an automobile initializer, and we're going to pass self into that the same way that we normally would. In this case, this is going to call the superclass's constructor for us and apply that to the self object. At the end of this code, when that line finishes, that automobile initialize, we will have the make, the model, the mileage, and the price already set for our object. But we won't have the doors set yet because we haven't done that. So the next line underneath that is where we set the attributes that are current only to the car. So this is not to every other type of vehicle, this is just to a car. And in this case, we do our self underscore underscore doors, because that's our private doors attribute. And we're going to set that equal to the doors attribute that came from our arguments. Now we have set all of the values that we need for our car in our initializer. On the next line down, we are setting our string overloaded function to be able to allow us to print out our object for our car. When we create our car, remember we have to pass that self object so it knows what the object instance is. And then we are going to use the string taken from our automobile class. The nice thing about this automobile.string, again, the same way we used initializer, we are going to take our object and print and get the string value that comes from the string overloaded operator. Remember, the string overloaded operator always returns a string. So we will have gotten the make and model with the mileage already as a string, and then we can add in, it also has 2 doors, 4 doors, 6 doors, 8 doors, however many doors we need. By the way, don't forget doors is an integer value, which means we need to cast it to a string if we're going to concatenate it this way. Remember, we're turning an entire string value with this. So we're not just printing, we're not going to print these out in our string method. We are actually returning the string itself. So just the string literal, and then that gets passed into a print method at that point. And we also have our getters and setters, but you notice we don't have to have getters and setters for our make and model and mileage. We only need getters and setters for our doors, because those are the only things that are unique to our car. The rest of it is all done from our automobile. We can call get make and get model on a car, and it knows, because it's a subclass, go get the code from the superclass and run that method. So the nice thing about having this inheritance between the two is that we've inherited all those methods. We don't have to make them again. In this slide, we are adding 2 more subtypes to our automobile class. So we've already created our car. Now we're going to create our truck and our SUV. As you can see, there's only 4 methods in each of these. There's the initializer, the constructor, and the string overloaded method, because we need to have those 2. And then just getting and setting, or our getters and setters, for the attribute that is different about this one. Our truck, we have given it a drive type, 4-wheel drive or 2-wheel drive, because sometimes that's something we would need to know about a truck. We don't really worry about doors. I mean, you could do 2 doors or 4 doors if you have an extended cab, but in this case, we're not worried about that. We just want to know, is it a 4-wheel drive or a 2-wheel drive? Is it an all-wheel drive? What type of drive type do you want to use? So in this case, we've altered our initializer, again, to take those first 5 attributes and then add drive type as the next one. We call our initializer from our automobile the same way we did with the car, and then we add in the self dot underscore underscore drive type to add in that drive type value. We've added to our string method to say, as a truck, what is its drive type, and then we've added our getters and setters. For our SUV, you can see we've done exactly the same thing, except we've added a passenger capacity. Some SUVs can hold 5, some can hold 6, some can hold 8, depending on the SUV that you've picked. So we want to add in a passenger capacity. Again, we changed our string to add that capacity piece of information, and our getters and setters for just passenger capacity. All 3 of these types can use the get make, get model, get year, get price, get mileage from our automobile class, because they all inherited from it, which allows us to do the next slide. As you can see from the putting it all together slide, this is where we create a main function, and we have our car and our truck and our SUV as 3 different types. Now, if you wanted to store all of these in a separate file, remember you'd have to import that file and reference the file name before the car, truck, or SUV constructor. So you would do vehicles.car, vehicles.truck. But in this case, if they're all in the same file, you don't have to do that. In this case, we've created a car, we've created a Mazda, and it had seating for 5. No, it had 5 doors because it had a hatchback. We have a truck that is a 4-wheel drive, Chevy F-150, and then we've done our Ford Escape for our SUV that has a passenger capacity of 5. And you'll see the string methods on those 3 worked beautifully. We could just say print the car, and it prints out the name and the model and the mileage and the price and whether or not it had what its door size is. So being able to code reuse or use code from previous methods is part of the concept that gets into object-oriented programming. At this point, we're using objects as opposed to just doing string literals. We're using objects to be able to store attributes and then of course have the code reuse of being able to inherit from those classes. When we store our class data, we like to document it and make sure that we understand, not only from our point of view, but also from everybody else's point of view, what that class diagram looks like. In this case, we're creating something called a UML diagram. This is a unified modeling language. This is similar to the same one that we used in our classes in chapter 10, but we've extended this a little bit to add inheritance. We have added an arrow and the class names below the superclass. So we have a superclass of automobile, or a parent class, with all of its methods and attributes. Remember, private methods go on the top in the first little box, and then public go in the second little box. You do not have to use the self because it's assumed. And then otherwise you include what the parameters are that are included. In the subclasses or the child classes, you want to include just the methods and the attributes that are associated with that class. Which ones are you creating in that class? Because in this case, you are going to be just having the doors or the drive type or the passenger capacity in those subclasses, but you don't need to re-add the make, model, mileage, and price because those are assumed. They came from your superclass. The notation that we use is simply an arrow. So we have this notation where each of these different ones has an arrow that goes towards its superclass because that's what it's inheriting from. So when you write your UML diagrams, this is what it should look like. Obviously, it'll have different text depending on what your class looks like, but it should look similar to this. At this time, I'd like you to go do the project between 561 and 565. This is a savings account object, but it also is a superclass because you're going to be creating a CD type of savings account. CDs are a little different than regular savings accounts. So certificates of deposit, if you don't already know, they have a maturity date, and at that date, they come up to their max amount. So they mature at a certain time. So you could get a 3-month CD or a 6-month CD or a year-long CD, 5-year CD, and it has a maturity time. So at the end of the 5 years, you can have your money back and plus all of the interest, whatever the time was. So if you had a 3-month CD, you can't touch the money for 3 months, different than a regular savings account that you could touch anytime. So you're going to create a regular savings account class, and it's going to have an account number and an interest rate and a balance. And then you're going to create a CD class that's going to also include that maturity date. This will give you an example of being able to play around with inheritance, being able to create a superclass and a subclass. Don't forget to include the main program and make sure that you test both of your classes. I want to create regular savings account and I want to create a CD, and make sure that both of them work right, that you get your string data in there, your string overloaded function, your initializers work, and you can get all of your attributes back out. So go have fun with that and then come back when you're done. In object-oriented programming, we use a concept called polymorphism, which simply means many forms. So poly meaning many, morph is form. So polymorphism just means that we can turn methods and have many versions of them, the same way that we have done polymorphism with our initializer and our string method that we have overloaded. You've heard me say it a few times by now. We already did this, and I may have explained or used the words without really fully explaining them. So it allows your subclasses to include the same method name in their own form. So whatever form the subclass wants to have. So when we do our string method to allow us to print out our object, we want to change it a little bit for our subclasses and make the subclasses a little bit different. And we can do that even though if we had an automobile, it would print one way. If we have a car or an SUV, it prints a different way. This is the polymorphism we're talking about, being able to have many forms of the same function. You can call the function on your object, and the object knows what its type is. So it knows which method you want to use. If you want to use the superclass version for whatever reason, say we wanted to print out just the automobile version of our string instead of our car version, you can. You just have to call it with the class name and then the period and then the underscore string method at that point, or whichever method you want to change, and use the superclass. You can. The same way that we use the automobile.initializer inside of our initializers, that's calling the superclass version. If we just tried to create new car inside of our initializer, we'll get an infinite loop. You'll be calling yourself inside yourself, and then it just keeps going around in circles. So we can call the automobile initializer. That's how we do that, with the automobile dot and then the initializer function. You can do that with any of your functions from your superclass. Just call automobile dot and then whatever your function name is. Or whatever your superclass name is. If you want to use the subclass version, you can really just call the method, but if you need to specify that you want that one, you can always use the self, because it's whatever type goes along with self. In Python, we have a method that is a Boolean method called isInstance that allows you to put an object and a class name in the parameters, and it will return true if the object is that class type. So if you want to check ahead of time to make sure that you are a certain type of class, you can use the isInstance method to run through and say, is this a mammal? If it's not, then don't ask it, how many arms and legs it has or whatever. Don't ask it whether it can speak, whatever the word is, whatever the function is that goes along with being a mammal. If we want to ask ahead of time, is this an automobile? Because if we don't want to try to use the getters and setters that go with automobile, and if we don't know that it is an automobile. So we can use the isInstance just to check to see if the variable that you are using is a certain type. Remember, if that certain type comes from a different file, you need to reference the module by saying whatever the file name is, dot, and then whatever the class name is. All right, that is the basics of chapter 11. Yes, I do expect you to read the chapter. There's a couple of things in here that I haven't really gone over, but it's not that long of a chapter. So it really covers this concept of polymorphism and being able to have super and subclasses. Your homework is not out of the book, so you have to be watching this video to get your homework assignment. For your homework, you are going to pick one of the 3 types I have listed here. You are going to pick either fruit, so bananas, apples, grapes, oranges, apples. I think I said apples twice. RPG weapons, because they're a kind of fun one to do. So swords or crossbows or magic wands, something along those lines. Something that is a weapon that has methods. Or you can pick Minecraft blocks. So Minecraft was really big about 10 years ago. Some of you may still be comfortable with the concept of Minecraft blocks. But Minecraft blocks have different attributes that go along with them, different things that they can do, but they all kind of follow the basic concept of what's their color, what is their name, things like that. They still have the same attributes for that. And then there are subtypes, different types of attribute of Minecraft blocks. You have to pick one of these 3. Because I'm trying to get you away from the book and into thinking on your own. You are going to create a superclass that is going to be one of these 3 names for the class type that you picked. It has to include at least 2 attributes and 2 methods, a constructor and a string, a 2-string overloaded method. You also have to include getters and setters for each of your attributes. So if you are only going to choose 2 attributes, you should have 2 getters and 2 setters. You are welcome to add as many attributes as you want, but you have to have at least 2. So if you want 3, 4, 5, whatever feels comfortable for the object that you've picked. You are then going to create 2 subclasses underneath that first class. You can have more than 2. You can have 3, 4, 5, depending on how many subclasses you want. And that's totally acceptable. You can also have nested subclasses, so subclasses under subclasses, because you can do that. These subclasses must make sense. So if you're going to pick fruit, please don't pick square as your subclass, because that doesn't make any sense. Don't pick magic wand as your subclass for a Minecraft block, unless you want the magic wand Minecraft block, which does exist. Anyway, you need to have at least 1 additional attribute and at least 1 additional method that goes along with that object. You must override both your initializer and your string methods. You're also going to create a main, so some sort of a demo that is going to create and print the instance of your supertype and each of your subtypes. So you will create a new fruit, and then you will create a new banana and a new apple. Fruit doesn't really have much in the way of methods, so you're going to have some creativity there. What do you want to make the method, what do you want to make the fruit do? And then last, you need to include a UML diagram for both your superclass and your subclasses. So both of your subclasses, or however many subclasses you end up with. This is a creative thing. You're going to go out and you're going to come up with these objects on your own. This isn't something that comes straight out of the book. There is no right answer as long as you follow the requirements. So you have to use one of the superclasses I've given you, and you have to create at least 2 subclasses. You have to have the required attributes, the required methods, the required getters and setters, so on and so forth. So try to have some fun with this. This is starting to come out on your own and letting me really see your personality. So have a great week, hopefully. Let me know if you have any questions.